Okay, perfect. Good. Ah, but use. No, okay. Yeah, no, let's just wait because they're about Test, test, test. Okay, looks good. Great. Then welcome everybody to the fourth year. So already the fourth of 5 days. Time is always, at least for us, passing super fast. And as always, I want to give a quick recap of yesterday, introduce the program of today. So welcome back, and today we're gonna have greetings. We have greetings from my second personality, and let's listen at it. The president of the German chapter of the Association for Computing Machinery. The ACM is the biggest association of computer science professionals worldwide. As German chapter, we are super happy to co-sponsor this 6th edition of this very successful PhD school that is always covering super important topics. And this year's topic, IoT meets supply chain, is of course central for the challenges that our society faces at the moment. It's a topic that is still a bit hidden because it's not so obvious for people what it is, a supply chain, that it can be hardware, but that it can especially also be software. And therefore we consider the topic highly important to be covered, especially from this rather research-driven activity. Our motto is that our members drive computer science in practice and also research, and this goes into that sense. Without further ado, I wish you a great week. I hope to get some feedbacks from you. Maybe some of you want to become members of our society, which is also the oldest regional chapter of the ACM. And I also hope to see many of our members online joining the event. Enjoy. Okay, and the reason why I used the video is that all the greetings will be online, and therefore I appreciate so many things going on that I just didn't find the time to do it beforehand. And so for those of you who are in Germany, you're more than welcome to become a member of the German chapter of the ACM. It's our an occasion to meet, to exchange with experts, and so it's this thing where I spend some of my time being the president of this German regional chapter, and this is how I am in this circle of the Heidelberg Law Forum where I was talking to you about 2 days ago, I guess, because this was also co-founded with the German chapter back in the days, because Klaus Tschira from the foundation, so one of the SAP founders behind, he also did his studies in Karlsruhe and so on, and he was also closely linked to the chapter. Okay, good. Yesterday we had the keynote by Mina, then afterwards you were working on the Makeathon, then we had the keynote by Laurent, and then you had more Makeathon, and we had very nice food yesterday evening, and some impressions from yesterday morning, and that reminds me that I forgot to put the picture from this morning. It's a little bit more foggy today. So yeah, Mina was giving a first keynote, and then afterwards there was a hands-on with learning, which probably was quite interesting. At least it looked very interesting to me. And then Laurent was talking about the internet, and also linked to tomorrow, where we'll have the AFNIC event. And yeah, so some impressions. So during the day we managed to get milk, which was also very nice. And besides that, yeah, we had the presentations. We also have the animations from the intro running now, and you will very nicely. And yeah, some more impressions through the day. And yeah, so it's so these impressions will be even nicer to you in some weeks, because then it will be, the event was very exhausting, and then it will shift into, oh, it was a nice cozy place, it was a cool thing, nice memories, and the photos will support you a bit with that. Okay, so today we have, I will introduce him in a second, and then you have time to work, and then we have, so it's not updated, then we have the keynote that was skipped, so Kartik will give then at a keynote, and so his daughter is still ill, and he's not sure if it's COVID or not, and therefore he didn't want us into danger. He will be giving the keynote at distance. We'll connect him remotely. And yeah, then you have time to work on the Makeathon. And in the afternoon we have Gael, who should physically be here and do something with us about connected vehicles and their security. Of course, also a big supply chain issue as we talked. Then you have time to work again a bit on the Makeathon. And then we have Michel, who will present to us the PTCC, so the program de transfert au campus cyber. And at 6 or at 5:45, we have to be at Centre Pompidou. Erkin was already looking it up, so it's quite easy to get there. So if we manage this should be totally fine. Then we have 1.5 hours in the Centre Pompidou. I will tell more about it later, which will be also very nice. And then we have a joint dinner in the city center today. Okay, so this is the program for today, and the keynotes, as said, are those. So these are the 3 keynotes that we have today. And I just switch back to Servann. The title is The Computer Security Journey of Critical Industrial Assets. Super relevant topic, and I'm super happy that you're with us. So thanks a lot for having taken the time or taking the time. And Servann Pigault is a cybersecurity control engineer at Framatome. And you got to know also Erkin, and Servann is the boss of Erkin. And so, therefore, more than warm welcome, and I hand over to you.
Thank you. Thank you very much. Okay, perfect. So thanks for the welcome. And so what I will try to give you a look about today is what we do in a specific industry, which is the nuclear industry, on how to secure industrial assets, which can be very sensitive. Okay, so this is not really. So I will go over a few topics, starting by a short introduction about us, so that you understand who we are. I'm pretty sure that you're not really familiar with Framatome and our activities. Then I will go through some principles that we have to apply in the nuclear sector, which is a little different from other industries due to the safety requirements that we face. Then I will go to actually the journey, what we call the industrial security assets journey. And with then 2 focuses on one on the topic we call hardening, and another one on the computer maintenance during the operation phase of the systems. I will try to give you some overlook of the next steps for us and the industry. So, as an introduction, just who are we from Atom? We are a big company which is part of the EDF group that you might know better. And our job is to design, build, and provide services to nuclear steam supply systems. And in particular in this, which means we provide big components that are part of the primary circuit of a nuclear power plant, but we also provide many other activities like fuel systems, and also industrial systems to control the plant. We are mostly located in Europe, but we service and we provide systems in the whole world, including the United States and Asia. And the reason why I'm here today is that one of our activities is linked to industrial systems. And by this, what we do mainly is in one of our BUs is called INC, which means instrumentation and control. And it corresponds to the kind of the brain of the nuclear power plant. You have on close to the process sensors, actuators, interacting with the process, and then between this and the operators, human beings, they are now digital systems composed of automation computers, of servers, of HMIs, in order to be able to interact with the process. Process information coming from sensors, give order to actuators, register what is going on, and so on and so on. So our job in this activity is that we design the systems, and afterward we will provide capabilities to our customers to deploy that on sites, so new builds, but also modernizations, because older systems used to be, for instance, completely analog. Now they are digital. There are changes. a life of around 40 to 60 years. So in the meantime, we will have to change. The operators will have to renew parts of systems. So because at some point they will get obsolete, and they will age. They will not be relevant anymore, and projects of modernization will have to come into. But also instrumentations, simulations during engineering, and on top of this, cybersecurity. So cybersecurity, when I said it at this stage, it's almost obvious. Why cybersecurity? Um, 30 years ago, 40 years ago, we were managing fully analog systems, so no cybersecurity problems. And now everything is getting digital. So the PLCs are digital. We put computers for every single thing. Any system that you will put in a plant now has its own maintenance and configuration laptop. So we put computers everywhere. And of course, this comes with cybersecurity issues. These computers, these servers, they come with standard operating systems, some pieces of software that are from the market, plus some software that specific software, system software that Framatome or other industrial companies will develop and support. So we have to integrate in our products things coming from supply chain, like operating systems typically. Good guarantees that what we deliver to them is something that is secure with regard to integrity, confidentiality, and availability criteria, depending on the needs. So to do that, to provide security on that, just a few principles on the nuclear sector. Here you have an overview of all the standards and the regulations that we face. Basically, every single country has its own authority, a safety authority, which considers their own requirements. Typically in France, we have requirements coming from the military programming law on some systems, but it will be different in Germany, it will be different in the US. And this is the law, this is part of the law. And on top of this, we have standards that are coming from standardization bodies. So typically IEC, ISA, and in other countries, NRC. Typically, these specific standards, IEC, SC45A, Working Group 9, they are standards that are fully addressing computer security, cyber security for safety and non-safety systems that are put in nuclear power plants. So they are quite relevant to us. And basically all these standards and regulations, they all come down to the same principles, so I will just go over a few. Architecture level, physical security, and finally organizational security. And we do that during operations. I mean, our customers, the operators do that during operations, but we also, as a supplier, have to implement such concepts in the way we work when we prepare, when we work on during engineering phases, on the system software, on the application software, on the hardware that we will deliver to the customer as an assembled system. So this is quite important for us. Second aspect is another key point is the graded approach. Sorry, not graduated. The point is to say that the different systems that are in a plant, they all have a different security need or security. So they are assigned each of them with a security need based on the functions they ensure. What is it something that is really relevant for nuclear safety? Is it something that is a side system? We don't and put all the systems in this zone, in these degrees, in these levels, and group the assets. And then all the degrees or levels are associated with a catalog of requirements. So it means that for an operator, basically, or somebody in charge of building a power plant, they will have a catalog of requirements to send to the different suppliers that are providing systems. Typically, Framatome, and we are providing systems here on the center, but there are dozens and dozens of other industries which are building other systems, and sometimes these systems will have to communicate with ours. So it's very important that we have these rules that are consistent between the contracts, between the different activities, so that in the end we are talking about the same thing. And this approach, it's present in the nuclear world, but it's also something that you can see in other industries. Typically the IEC 62443 is talking about that. There are guides from the ANSI in France that are talking about this. It's very, very common. And just here to say that everything it's the different standards, they might take different namings for their levels. The requirements might be a little different, but in the end it's the same approach. So, and finally, something about just to put some ideas on what the role or the roles of the entities, suppliers, and the contracting authorities on projects. We are again on a nuclear power plant is quite a complex thing. We have lots of systems on that, and we apply the approach that I've just described to apply security requirements. And also there are, of course, relationships between the person who is asking and the entities in charge of designing the systems. So basically, the operator or another entity is acting as the contracting entity and authority, and is specifying the needs, including the catalog of requirements, the level of systems, and so. And the companies in charge of providing systems will act as project management, and they will have to take into account the needs expressed by the contracting authority and enforce that into their systems, into their architecture, ensure that it is properly integrated and validated, and then install that on site. And in parallel of all these activities, the contracting authority will have to audit and manage the contract to ensure that the suppliers are working according to what they expect. On nuclear projects, this phase, it can last something like 10 years, 15 years, and more sometimes. You might have heard about the Flamanville 3 project. It started around 2006, and we have just loaded fuel into the plant, which means that it's just starting in 2024. So over the span of 2006 to 2024 and after, the EDF, which is the operator, has to ensure that all their suppliers are working according to expectations. And us, Framatome, as a supplier, we have to work according to the expectations of our customers, and we also have to ensure that our own suppliers same. And this brings me to, now that I've pushed the topics on the key topics on the table, our journey, the way we work, how we consider security. So this is just an overview of the topics that we have to deal with as a supplier of systems and provider of some security functions to our customers. We have to deal, as I said, with organization. We are doing cybersecurity activities, but we are also doing engineering, HMI, the functions, hardware, electrical cabling, and so the software development. We have to ensure our customers that what we are doing is done according to practices, and what they will get at the end is something that is okay from a security point of view. In particular, every that we will deliver to them is really good from an integrity point of view, not compromised. Then our systems, as I said, they are digital, so we have to integrate security features in there so that they are able to protect themselves from a security point of view if an attacker were to try to get into that when they are in operation. And then on the middle, starting the asset management phase, it's something that that can be done other ways, but that Framatome has developed or purchased some software, some products in order to support the customer ability to perform this task during operation. Typically, know your fleet of assets on a plant, understand what is present, be able to know what are the vulnerabilities when the system is running, remediate, and so and so and so, and go to the ability to monitor the assets when they are running. So basically, what we have to cover is the complete phase from starting from the design up to the maintenance when a system is in operation. And if you look at what just V-cycle, that's something that you might be aware. That's something we apply for the engineering phase of a given system. What we have to do from at home is first everything we will do, whatever it is, technical, organizational, we will have to ensure a layer of governance, compliance, risk assessment, awareness of the team members on the risk and the measures that they have to apply, and control ourselves. Are we working properly? Are we ensuring our customers with a suitable security level? Then from a technical point of view, what you see here, we have two different periods. The first one being the period when the system is not running, it's not installed on site, and we have to do some design, we have to build the system, we have to test it. So the activities I've just presented before, we go into the V cycle. Basically, specification, risk assessment, sensibility assessment, design of an architecture, integrating cybersecurity features, hardening, that I will just present after, testing, and then integration on site, etc., etc. And what you see here is that we have different paths for different categories of systems. I talked a lot until now about systems which are important to safety, the ones that basically are supposed to be there when the plant is running, so in order to ensure that we will not have nuclear leaks, that we will not have accidents related to nuclear safety. Typically, it's systems that that will control the way the nuclear reaction is going on. These systems, they are submitted to all the standards I've mentioned, and they are, due to their sensitivity, the rules are quite heavy, meaning that when we want to modify them during later phases, we will have to go through the same cycle, complete cycle as this one. Typically, if there is a vulnerability on Linux on a system that is installed which is a safety system, I cannot go to patch it, even if it's quite critical, because there is a risk of regression on the system, which is absolutely unacceptable for the operator. They must have this system completely working as expected. So we will have to go through the complete cycle, retest, requalify, and then benefit from an outage. An outage is basically a time when we shut down the plant to do some modifications and launch again the plant. And there are other systems, things that are not important to safety, like maybe some side monitoring topics, some testing equipment that are necessary for the operator, not necessary for the customer, but they are not important to safety. So for these, we can have a different strategy. Typically, patches, modifications, maybe they can be brought in a much faster pace and not wait for outages. Because here, when I was talking about outages, you can consider that it's not less than 18 months between two outages. So quite a long time with regard to the usual patching approaches that are recommended for the IT world it's generally a few days up to 1 month, but not more, not more. And here we could consider something that is much closer to that. And these two paths, they are proposed to our customers depending on the sensibility of systems and also depending on the industry. This is really, really specific to the nuclear industry, and others, which are less critical, could benefit from such an approach. So for that we have, but that's not relevant today. Here then I will go into two topics, hardening first and the topic of maintenance. These topics are, the hardening is a topic which is quite done. It means basically that it consists in configuring systems so that they are really secure, like a standalone machine, a computer like you have today. You want to reduce the system features so that they only do what is needed, and you want to apply security configurations as much as possible. This kind of thing is quite difficult to do on machines which have heavy changing regularly, like computers we use for doing office activity, the computers you use at home or for your PhD activities. Sometimes you want to install software, you want to remove something, maybe put a game. It's quite difficult to have something very constrained. While in our world, a machine has been designed to do only a very limited scope of activities and will not change for maybe 18 months or more. So we have a really good opportunity here to go very far in the hardening possibilities, meaning that our key activity will be to ensure that every single machine that we can configure will be going through a thorough hardening. And it's also something that is difficult to do because it needs a really deep understanding of how the system is working, what are the dependencies, what are the software, what are the network communications, how the user is behaving. So this is something that you can do, not easily, but that on technologies you master, but that gets very, very difficult for old software that is not well, for which behavior is not well known, for integrations coming from different suppliers. So that's a really challenge. That's quite challenging. And from a technical point of view, what it means that you take typically a computer or server and you start by doing a minimal installation. Then you just activate the necessary functions, logging, access control, the piece of software that is necessary, the software dependencies, security policies, and something like that. You can do that manually, but it takes ages. And what we have tried to implement on our side is to automate that as much as possible. And basically, we try to automate. When I say automate, it means that we are developing some scripts that will be able to rerun over time on a machine if we need to reinstall it. And if we have to install dozens of the same computer, which might happen on some systems, then we are able to redeploy something easily. We are able to modify something easily as well. While if you just have a manual procedure, it takes maybe 1 week to install a computer, while you don't have this time on site. And also this supports the needs of our customers, because they now request us, okay, to prove what we say we do. So we have to ensure traceability from their requirements, the graded approach ones, from the specification up to tests. So having scripts, having tools that allow us to point exactly where we have implemented something, one feature or another, is really important to give confidence to the customer and also demonstrate that we have worked properly. This kind of approach also helps having adapted modules. Like machines are behaving differently. You cannot always apply exactly the same recipes, but you can work in a similar way. Typically, machines have different network communications, so you cannot say, okay, I will block everything. But you can configure a firewall or a policy in a very similar way. So what we are doing now is that we are developing some individual bricks, like basically how to configure a firewall, how to configure a password policy, and then we will configure that specifically for a given project, a given system. So that's really, really important in order to have reproducibility, auditability, traceability for our customers, and also on our side, efficiency. Because if we have one computer to harden, okay, it will be done in few days. If we have dozens of computers to harden and redo that over time, it can be a huge loss of time for us, but also for customers, and it might ramp up the price of our activities significantly, and make that affordable for us, but also for the customers. So there is a challenge of efficiency from security point of view, from financial point of view, and from planning point of view. Just a quick insight on what is happening on an outage. An outage is a constrained time period when an operator will ensure that some activities are done, maintenance activities, change some fuel, and so. It's planned, and there is a time frame that is quite closed. Every day of that of delay will cost something like 1 million euros. So delays are not acceptable for a single PC. You have to make sure that you can work in an efficient way, that you can meet the customer needs, so that everything enters in the schedule. So this is now one of our challenge. And finally, why hardening? That's something I forgot to say, sorry. But you might have heard about many security solutions coming from the industry, IT industry, like EDRs, XDRs, monitoring solutions, things that are controlling what is happening on computers. All that is very interesting, but unfortunately we cannot apply our systems because of certification, because we cannot control what is happening on these features, because the real-time constraints are not compatible with that. So basically, we are down to, okay, what can I do at this machine level? How can I segregate the systems from one to the other? Then how can I monitor? We are kind of late compared to other industries, but that's a challenge of nuclear. And finally, computer maintenance in security conditions. So besides the 20 or so years of project to prepare a system, then on a nuclear power plant you have to ensure security maintenance, and same on other industries. So for an operator having a plant, whether it is nuclear or not, a big challenge will be to have a knowledge of what is there, so that they are able to manage what is actually going on. They have maybe dozens of suppliers which have come to deliver installed things. If they have not taken care of building a proper inventory, they might not be even aware that something is there, like a computer or a piece of software, and so. So knowing what is there is really it's painful, it's not very interesting, it's not nice cybersecurity, but it's mandatory for the next steps. And then having this inventory will be important, will be very useful to be aware of the dynamic of vulnerabilities. If you have everything, you will know what is going on, what is happening. Our vulnerabilities release like CVEs typically, Linux, this specific network component that is part of systems. We'll be aware of that. And then the difficult point will be to say, okay, we know that there are vulnerabilities, but do we plan to patch them? Maybe some are not really applicable because the system is configured in a different way. We have constraints, and we will have to wait for 18 months until the next patching possibility during an outage. So basically, identifying the proper remediation is not as easy on an IT system as on an IT system. We'll have to discuss, propose things as suppliers, and we have to discuss with the operator, say what is the right way. And of course, since there are dozens of vulnerabilities going out every day, we will have to filter a little bit, because we will not be able to address manually each CVE that goes out. We'll have to focus on what is mostly important, what is critical, what is exploitable on a real system. Once we have selected what we will do, then we go back to what I was presenting, the way to implement. Will it be during an outage? Will it be during a fast-paced remediation plan? It will depend. And it could be maybe a short remediation organizational measure. Basically, we will come down to what we can do on the system. And finally, it will be deployed on the proper conditions. So all that is really key for an operator to ensure that over the 10 years, 20 years or more that one system will be running, they will be able to manage the vulnerability cycle. And finally, what's next? I focused a lot on just cybersecurity for these automation computer systems, which are not really IoT, as you can see them on the internet. But these topics are now getting into the nuclear world as well. As any other industry, we hear about 4.0 industry, we hear about cloud computing, we hear about Internet of Things, and for efficiency reasons, we are interested in these systems as well. I mean, nobody now wants to take a paper and takes notes in a nuclear power plant. They prefer to have a tablet with an application. They like to be able to get information in an automated way instead of having to read on a sensor. So all that is coming, and it will be for us challenges to bring security to these new features, to the new device that are of interest, even if not applied today. So we'll have probably lots of evolutions in the cybersecurity world for our and the new systems that are coming in the nuclear industry. So that's it for me. Thank you for listening. And if you have questions, I'm here.
Or the keynote, but it was super complementary to the others.
Ah, nice.
Therefore, it was really super nice, and I also seeing the more systemized approach for cybersecurity. We didn't have a talk in this PhD school, and so therefore it was really nice. I enjoyed it a lot. Which are the questions that you have?
Yes.
So you have all these different governments and organizations that you need to comply to their security standards. Do they ever conflict with each other, or
They rather go into the same direction with subtlety aspects that are different. Some are more specific than others on topics, but mostly they go into the same direction. They say to have inventories, they say to apply security, and they rarely say you need to apply exactly this configuration on this system. Usually it's more you have to have a policy for this, and this policy must consider this topic. Like for instance, vulnerability management, they say the regulations and the standards generally say that you have to monitor the vulnerabilities. They don't say how exactly or which extent. So it is possible to adapt in these, and the conflict is quite rare. It's more that they are all phrased a little bit differently. So you have done a huge work on a first set of standards because it's something key for a given project, and then you still have a lot of work to do for the second group of standards because the subtlety, the compliance assessment is not exactly the same, and you need to provide your customer with a proper answer. Really, are you compliant, and to which extent? Yes.
I found it very interesting that you said, like, with every new product or feature, you said features, I think there comes more also risk for you, right? You want to reduce all these risks, and so also use less features and also less use security features. That's interesting, I feel like, because new security features on the one hand are supposed to be bringing more security, but also in your view they also bring more insecurity because of their complexity. It's more code you get from the outside. Do you have this idea also for working together with other companies or other institutions? Like, do you because I know that many companies, especially smaller companies, externalize everything with regard to security. they maybe don't even have a security expert in their company. So how do you do that? Do you do the most things on your own then?
Yes.
Okay.
Basically, we have to provide our customers with guarantees that we will be able to provide answers to support them over a huge, a long period, like 10 years, 15 years. We just signed a contract for 20 years duration. So if we want to be able to support them, it means that we must have internal competencies that we will be able to manage over time. So there is a huge part of internalization that is mandatory, else we will not be able to serve our customers. So we have now a team of, in the topic around our INC. For cybersecurity, we are now more than 50. And sometimes we can have subcontractors, we can have a partnership with a company, but we try to have our core knowledge internal. Plus, we have developed some products and we have purchased some products which are cybersecurity products, like CyberWatch, you might have heard about it, or FoxGuard, and we try to use these ones on our own systems, and plus sell them outside to other customers, so that it's yes. So point is serving other industries help us to serve our core business.
What would you say is the impact of softwareization in your industry? Is everything going more to software, and is that making your life more easy or more difficult?
Yeah, everything is getting to software. Lots of things are getting to software. We still have some analog system, in particular for backup of some safety systems, but we now see that there is an interest of having software everywhere because of getting more information, being able to process more data, and so. There are two aspects on that. If there was no software, I would not have a job in Framatome. So definitely, it's a good thing for me and for the team. But it's also kind of a pain, because it means that sometimes we have tricky topics to address. So it is both a challenge and an opportunity for us. It's a new business. 20 years ago, we were not doing cybersecurity in the INC world or even in the nuclear world. Now it has become a very, very important topic, and it keeps growing. So.
And related to that, connectivity, so is the remote controllability significantly enhancing? Do you think it will continue to enhance to become more?
Today, for the most sensitive systems, it's completely out of question. It's not allowed, so we don't do that. This kind of topic can be discussed for other systems. So we are not working on this one, so I don't exactly know what is the status. But typically, with the new small modular reactors, which are much smaller than nuclear power plants, there are these concerns on how could it be relevant to control them remotely. The answer is not available yet from a cybersecurity point of view. It will be a very interesting topic for probably the next 5 to 10 years.
Okay, cool.
No answer today, sorry.
Okay, no problem. Very good. And is AI playing a role? And besides the general question, a more concrete question is, AI is, it's not really true, but it can be considered to some extent non-deterministic in its behavior because it's probabilistic. And so is that an issue in your industry? Are there AI-based optimizations of nuclear power plants? Are there continuous AI algorithms running? I would expect maybe not yet, but do you think this is something that will come? And from also expertise in general on cybersecurity, do you think we as cybersecurity researchers, practitioners, and so on are already enough prepared for that? Is the V model prepared for reacting to AI-based software control?
What I can tell you is that today, compared to other industries, AI is really at a starting on our side. Lots of projects on how to benefit from it, typically during the engineering phases, where we are not directly connected to the plant. Basically, it's more optimization of the works, the painful works that we have to do. Typically, classification of requirements, getting answers into existing documents, now, better processing of lots of this information. So today we are kind of prepared for that because it's if tools give information, we are really to have this loop of checking what is happening, is it okay or not. So even if we have been helped on with an AI, we will check what is done. It's part of our process. And we are not yet on part where we will put AI modules, AI capabilities into our systems from a technical point of view. So for this, we are probably less prepared, but it will be topics that are studied over time.
And on the customer side, like on the, I mean, not from the cybersecurity side, but rather from the operations side, do you think there for safety critical applications AI will also increase, or is it still like that one says, okay, so it's safety critical, we have standards to meet and so on and so on, so AI is really far because it cannot be standardized, it cannot be certified, especially today, and so therefore it's definitely, it's probably something that will not come in the next 5 years at least.
Probably not in the next 5 years. Everybody sees a potential interest, so there will be activities to check, to see how can we qualify, how can we get sufficiently confident into that, and then how to integrate this in the standards, because also today in the standard is not present because it did not it doesn't exist. Basically, actors from the nuclear sector have to come together and talk about this. So I can tell you that now AI is a topic that is studied by the IEC working group. New thing. How do we deal with that? So really, it's not not the very short term, but something that the industry will tackle.
Cool. Do we have more questions? If not, so it was a great talk and great discussion, so thanks
very
again.
much.
And also for you, I mean, you stay as long as you have time today. You're also invited for lunch, obviously. But also for you, the speaker certificate.
Oh, thank you.
Even with some 3D imprint
Oh,
at the bottom.
Wonderful.
And you also have some stickers, postcards, pens, and stuff like that.
Thank you very much. And
Yeah,
thank you for
inviting
me.
And yeah, very good.
Thank you for the
very good. Let's make just a photo together, then we also have a photo with you. Could you make a photo of us here in front of the presentation? But Servann is also quite tall, so
much less.
very good.
So thank you.
Okay, thank you very much. And so for the next talk, as I said, it's remote. That means give me 5 minutes. I will prepare everything so you can get back a little bit to your stuff. I will prepare things with Kartik, and I will come back once we start. Oh yeah, Kartik is there. Kartik, do you hear me? Okay, you hear me probably? Perfect. You're still on mute. And let me just put you on. No. No. To Zoom, yes. No, but this will be used for. Yes. So for you, everything is normal. For you, nothing will change. But there won't be speaker in front of you. There will just be no physical speaker, but instead of the speaker slides, you will see Kartik here in a second. Let me just put the OBS, and then we can try it with Kartik. So I see you very well. This is already very nice. So the slides were also up until a second ago. So if you, yeah, okay, so they're back. Okay, perfect. Let me just share this. So check full screen projector here. Okay, that looks very good. So the only thing we have to, so look, everything looks great. The only thing we have to check is that we have your audio in a way that you're well audible. And so for that, I will just go to the front. You will also see me then on the camera again because you have the room camera. So, okay, so now you should be able to see me. And maybe once you're ready, just say something, and then I can check if I hear you. So I don't hear yet, but it might be my computer. Ah, no. So the thing is, yeah, it's there. So I will have to switch the audio out. Give me a second. Check. Because it's a quite sophisticated setup. It's a pity you're not here to see it. So so this is good. For this one, we have to also enable the audio for it is right. Okay. So in general, it should be okay. So it's two here. Okay, and yeah, maybe say something. Okay, here I see you. So that way. Yeah, okay, no, I know where the problem is. So now say something.
Where I am, speaking aloud.
Okay, it's perfect. It's perfect. Good. So we can volume it down here a bit, and you can volume it down here indeed. So let's just Kartik just speak. Wait a second.
Yeah, this is Karthik here speaking.
Just talk a bit.
Yeah, la la la, do do do. Bop, bop, bop.
Yeah, so here it looks very good, and you're also very well audible. So Akin is just checking for the second stream thing. Okay, but in general it looks very good. So then let me just start the streaming things. Give me 1 second for that. Stop this. Tick. Stop this. This. Tick. Okay,